The night was dark. Stars twinkled faintly in the sky above a small town not far from where you're sitting right now. In this quiet place, a mystery had lain dormant for over 50 years, until one day, an old piece of evidence began to whisper its secrets. In 1967, on what seemed like just another ordinary evening, a young woman named Mary was found murdered in her home. The case went cold almost as quickly as it unfolded. No fingerprints, no witnesses, and only a single strand of hair at the crime scene provided any clue. It wasn't much to go on back then. But imagine this scenario: you're standing outside that same house now, looking up into the night sky where those stars still twinkle. How would your curiosity be piqued if I told you that one day, that single strand of hair could unravel a decades-old mystery? It's like finding the key to an ancient puzzle buried in time. Back then, no one knew what lay hidden within that microscopic evidence. But with each passing year, science advanced, and so did our ability to solve these puzzles. Fast forward to 2017 when a team of forensic scientists received word about this cold case. They were given access to the old crime scene and asked if they could re-examine the evidence using modern DNA technology. Imagine you're holding that single strand of hair again, but now with tools so advanced that they can see individual genetic markers within it. It's like having a magnifying glass that can reveal the tiniest details hidden in plain sight for decades. The scientists began their work meticulously, knowing every step mattered as much as the next. They sequenced the DNA and compared it to databases of known offenders. And just when you might think nothing new would come from such an old case, they made a breakthrough. The match was clear: there was only one person who could have left that hair at the scene, someone named in the vast expanse of human history. Mysteries have always fascinated us. From ancient enigmas like the lost city of Atlantis to more recent conundrums such as the disappearance of Amelia Earhart, our curiosity about the unknown drives us forward. However, in a world that now relies heavily on technology and science, one form of evidence has begun unraveling centuries-old puzzles: DNA. DNA, or deoxyribonucleic acid, is the molecule that carries genetic information for all known living organisms. It's like a unique fingerprint, carrying an individual's identity from birth to death. Each strand of DNA contains a sequence of nucleotides: A, adenine; T, thymine; C, cytosine; and G, guanine, that spells out the instructions necessary for life. The story of solving mysteries through DNA began in 1984 when British geneticist Alec Jeffreys made an incredible breakthrough. He discovered that certain regions on our chromosomes varied significantly from person to person, a phenomenon known as polymorphisms. This finding laid the groundwork for using DNA analysis to identify individuals and establish relationships. Over time, advancements in technology have only enhanced this capability. Today, laboratories can process vast amounts of genetic data quickly, making it possible not just to match suspects with crimes but also to solve long-standing mysteries that once seemed impenetrable. One such mystery is the case of Jack the Ripper, a notorious serial killer who terrorized London's Whitechapel district in 1888. The identity of this elusive figure has remained unknown for over a century, leaving behind only gruesome murders and endless speculation. But recent developments have brought us closer to understanding his true nature. In 2016, forensic scientists analyzed the contents of 2 letters attributed to Jack the Ripper. These documents had been kept in archives since their discovery but held little scientific value until new techniques were applied. By examining the ink on these pages and comparing it in the vast world of unsolved mysteries, there's something undeniably captivating about the idea that a simple strand of DNA could unravel centuries-old enigmas. Throughout history, countless tales have been passed down through generations, tales of missing persons, unexplained disappearances, and even murders whose perpetrators remained unknown for decades or longer. Take, for instance, the case of Elizabeth Short, known affectionately as the Black Dahlia. Her gruesome murder in Los Angeles during 1947 left behind only a cryptic message, "To my dear and deep-dyed love." For over 7 decades, her identity was shrouded in mystery. But it wasn't until the advent of DNA evidence that a new chapter began to unfold. DNA, or deoxyribonucleic acid, is like a blueprint for life itself. It carries genetic instructions used in the development and functioning of all known living organisms, including humans. In the early 1980s, scientists developed techniques to extract and analyze this genetic material from crime scenes, opening up an entirely new realm of investigative possibilities. The Black Dahlia case is just one example where DNA evidence played a pivotal role. After decades without any leads, investigators turned their attention back to her case in the late 20th century. By comparing DNA samples found at the crime scene with those from potential suspects, forensic scientists eventually identified a man who had previously been ruled out due to lack of physical evidence. This breakthrough not only brought closure to the families involved but also highlighted how DNA can transcend time and technology to reveal truths hidden for decades. The power of this genetic material lies in its ability to provide irrefutable proof that can withstand the scrutiny of even the most skeptical minds. Yet, while DNA has proven itself as a powerful tool in solving cold cases, it's important to approach every mystery with an open and analytical mind. Just because something is solved through science doesn't mean we should dismiss other possible explanations. In the vast landscape of unsolved mysteries that have puzzled mankind for centuries, a new frontier has emerged. This is not just another story, it's an odyssey into uncharted territories where science meets history in a most unexpected way: DNA evidence. Imagine a small, weathered wooden chest found in a dusty attic, its contents untouched since the 18th century. Inside lies a piece of fabric, faded but still remarkably intact. It's not just any old cloth, it could be the key to unlocking one of history's greatest puzzles. This is where our story begins. The first step on this journey isn't always clear or easy. Scientists must collect samples meticulously, preserving their integrity and ensuring that nothing interferes with the evidence they hope to uncover. In a small lab in Cambridge, England, a team of geneticists carefully unwrap the fabric from its protective packaging, handling it as if it were a priceless artifact. DNA extraction is not just about breaking down cells, it's an intricate dance of chemistry and precision. The scientists use specialized techniques like silica-based purification to isolate DNA molecules from the cloth fibers. This process ensures that any contamination from modern sources can be avoided, maintaining the purity and reliability of their sample. As they work, a sense of anticipation builds in the air. These scientists are not just digging through ancient history, they're potentially rewriting it with every step. The next phase involves sequencing the DNA. This means breaking down the genetic material into its constituent parts to understand what makes up this mysterious piece of fabric. The technology used here is sophisticated, but it's also surprisingly simple in concept. Imagine unzipping a zipper that's been closed for centuries. Each rung reveals more about the person who wore this garment. The scientists analyze the DNA to identify specific markers and compare them with known databases of genetic information. This step isn't just scientific, it's detective work on an epic scale. Every piece of data collected is like a clue in a mystery novel. In the vast expanse of unsolved mysteries that have puzzled humanity for centuries, one method has emerged as a beacon of clarity: DNA evidence. This powerful tool isn't just about cracking cases, it reshapes our understanding of history, law enforcement, and even personal identity. Consider the story of Jane Doe 1972. For decades, her case lay dormant in the archives of a small town's police department. No one knew who she was or how she had died on that fateful night. Then came the breakthrough. DNA evidence linked to an unidentified body finally found its match in the national database. It wasn't just any name, it was a name with a story and, more importantly, a family waiting for closure. DNA evidence can also challenge long-held beliefs about historical events. Take the case of the Jack the Ripper murders that terrorized London's East End in 1888. For years, detectives hunted based on unreliable witness statements and speculation. But then DNA analysis revealed something shocking: one of the suspects had a genetic profile incompatible with the evidence found at the crime scene. This doesn't mean the real killer was never caught, it means that old assumptions need to be revisited. In the world of law enforcement, DNA has transformed from an afterthought into a critical tool. The first case solved using forensic DNA profiling was the 1986 rape and murder in England. The suspect was identified through a DNA match with evidence left at the crime scene. Since then, countless cold cases have been reopened, leading to convictions that would otherwise remain unresolved. The impact of these discoveries extends beyond just solving crimes. In many countries, there are now exonerations lists filled with individuals who were wrongfully convicted based on faulty eyewitness testimony or inadequate forensic science. DNA evidence has not only cleared the innocent but also highlighted flaws in our criminal justice system. This raises important questions about the reliability of human memory and the need for more rigorous scientific standards. Moreover, DNA as we trace the journey of unsolved mysteries that have been brought to light through DNA evidence, it's clear how far forensic science has come. Each solved mystery adds another piece to our understanding of history and justice. But as fascinating as these stories are, they also leave us with many questions. Take the case of William Montague Johnson. For decades, his family was left in the dark about what happened on that fateful day in 1897. The cold trail of evidence led them to believe their ancestor had been murdered and dumped in a shallow grave. Then, through DNA testing, they uncovered not just an answer but also a new question: how could someone be convicted based on circumstantial evidence if the real culprit was found years later? This raises important ethical considerations about the reliability of forensic methods at the time. Another case involves the mysterious death of 17-year-old Mary Fagan. Her murder has been debated for over a century, with various suspects ranging from John Wesley Dobbs to Newt Lee. However, it wasn't until DNA evidence was used in modern times that they were able to conclusively rule out certain individuals and confirm others as being far more likely culprits than previously thought. This suggests that sometimes old cases need new eyes, or rather, new technology, to uncover the truth. The story of the Jack the Ripper murders also illustrates how science can shed light on dark corners of history. For years, detectives struggled to find any concrete evidence linking specific suspects to the brutal killings in London's Whitechapel district during 1888. But then DNA analysis was applied retrospectively, leading investigators back through time and re-evaluating old theories about who might have been behind these horrific crimes. Each of these stories challenges us to reconsider our assumptions about justice and history. They remind us that no matter how much we think we know or believe, there is always room for new discoveries and revelations. The use of DNA evidence has not only solved cold cases, but not all mysteries have answers, but we keep searching. Subscribe to join the hunt.